There we go. All right, Michael. Thanks again for setting this up. I'm excited that we're able to connect again, and we want to talk a little bit about tokenization today, right?
Yes, please. Yeah, great to connect again, Ahmed.
So what was your kind of reason for the question around tokenization?
I was reading this article on Stripe's APIs, and whilst I broadly understand what the process of tokenization does, when it was getting into the specifics of how the token was used and that it was used to create a charge, I had some kind of follow-up questions on, why can't someone else take the token and create a charge? It's obviously supposed to be a lot more secure to do it, to process it in a tokenized way, but I just kind of wanted to delve more into the security element of it and why someone else can't just replicate what Stripe was doing if they're a nefarious actor.
Sure, sure. No, I think it's a really good call out, because so the way that it is that all these like infrastructure providers, be it Stripe or Square on the merchant acquiring side, or even Marqeta on the issuing side, they're all considered PCI compliant, meaning that they're able to store card data, meaning the whole card pan. So it's the 16-digit number that's on the card pan. They're actually able to store it on their side in a secure way. And so they go through an audit and all of that to be, quote unquote, PCI compliant. A vast majority of their customers are not PCI compliant. So, for example, when a store, like a web store, uses Stripe to be able to accept payments, most likely they're not PCI compliant. There are edge cases, but in most cases they're not PCI compliant, just because the overhead of that, it's so significant, right? And I think one of the things that Stripe did was it said, you know what, you don't need to be PCI compliant in order to be able to accept card-based payments. Now, I think the other key thing that's really nice about this is, let's suppose somebody was to hack into this online merchant's database. It can't really do anything, because there's no card numbers stored on that side. It's all stored with Stripe. And I think that's really where the benefit is. The process is actually very similar to when we're talking about Apple Pay and Google Pay tokenization. But I wanted to go through this first, and then let's talk about the Apple Pay and Google Pay thing, because I know that you'd asked me about that before, right?
Yeah, sounds great.
So if you look at the documentation that Stripe is providing, what it's basically saying is, again, the 7 lines of code, which is awesome. There's a JavaScript library that you use in your app. And then what it does is that you connect to Stripe securely using some sort of like RSA or something. They basically give you a secure way of connecting to Stripe. And then what happens is that you key in the card number, right? In many cases, it might be a web widget that Stripe is providing. So it's never like actually hitting your website directly. It's going directly to Stripe. And so what it does, you key in the 16-digit card number. And then what Stripe does is it gives you back a token, which is a completely different number. It could be longer than 16 digits. It could be shorter, whatever. But it's something completely unique. And the way that you authenticate it is, it might be, let's just say it's another 16-digit number that's completely randomized. When you go to actually ask Stripe to bill a user, right? So you buy a t-shirt for $25 on this web store. It's already registered you with the token. What happens is that when you decide to pay, it will actually provide to Stripe back the unique token that was generated. And then it also affixes it with the security protocol. There's some like randomly generated code that it applies to. And those two keys together will say, yes, this is Michael Jenkins' credit card. Please go ahead and bill him the $25. It provides that to Stripe. And then Stripe then looks in its database and says, okay, cool. This token is associated with this card number. Now I'm going to go ahead and charge it. Does that make sense?
That makes sense. It's the combination of this key and the token, and then that gets passed to Stripe, and they essentially I don't want to dumb it down too much, but it's like a VLOOKUP, right? They look up the token, and that corresponds to Michael, and my actual PAN number is XYZ, and they can charge it like that.
Yep, you got it. So that's what they're doing, and it's actually, I mean, it's the practice that they're talking about here. It's pretty common, across acquirers or gateways, just because it's really secure. It works, and again, it's the keys, right? It's the two together that actually allow this to happen. And again, it's great for the merchant because they don't have to store the card number anywhere.
So this key, the token and the key, who creates the key? Is that Stripe, or is that the merchant? Sorry, or someone different?
So Stripe provides it to the merchant on their behalf. So when they actually connect, right, they know that this is Ahmed's t-shirt shop, So that piece is generated I believe the way that it works is Stripe will generate it for you. And so anytime that you connect securely to Stripe, it knows that it's you.
And that key is it's just a one-to-one relationship. Every merchant just has one key, or does this key change dynamically or refresh to a different key at any point in time?
That's a good question. It's I don't know how it works on Stripe, but with our acquirer, it shifts, and there's different intervals. And so what it does is it gives you a new key every so often. You just need to make sure that you respond back with that key. I don't know what the cadence is on it. If it's like, I don't think it's per transaction. It's probably like maybe one a day or something of that nature.
Right. Okay. Because I guess that's the added security is, because if it was just the token, it's slightly more secure than having your card number. But, if you were just to hack a token and you could just use that, it's not that much more secure than just hacking someone's card number. But you have this key that changes dynamically, and that's what really makes it a lot more secure, because you need two pieces of information.
Yeah, because I mean, you could write down your key. I mean, whatever the gobbledygook number is, or the number is, you could just write it down and say, oh, okay, I want to pay with this. Stripe knows, okay, this is what it is. But if it's not coming from the right source, then it's problematic, right?
What do you mean in terms of coming from the right source?
So in some places, they might be like a whitelisting process, meaning that if the transaction is coming from a whitelisted source, like a whitelisted server, for example, then that's one additional layer of security on top of it, right? So you've got that one other piece.
Okay, that makes a lot more sense now. I thought, originally a token is just obviously a randomized number, and if you can steal that and that's all you need, then it's no different to kind of stealing a PAN. But obviously there are additional measures like the key and this whitelisting that make the whole process a lot more secure. So that makes sense.
And I think when you start thinking about like Apple Pay and how all that works, I mean, there's like device level security that's happening there. It's probably the most secure way of transacting is actually through an iPhone. Is just because if you don't mind, I'll shift gears a little bit. So what happens on Apple Pay and Google Pay is that you have your 16-digit PAN, and what happens is that you send that 16-digit PAN through your processor, your issuer processor, over to MasterCard or Visa. They basically would generate a token. And then what it does is that it sends it back to your iPhone or Android device. In the case of Android, it actually stores it as part of a cloud key. On iOS, it actually stores it on the device. And so it stores it in that, they call it the secure element, right? On the device. And so there, that token is stored. And then on top of that, you have the secure element that doesn't allow anybody to access that token unless it's you. So even on the iPhone, Apple doesn't even have access to that. It's completely only on your device. And so that way it's actually very secure in that. I mean, if you're stealing somebody's face, or if you're stealing somebody's thumbprint, sure, you'll be able to get in, but it's pretty damn bulletproof for you to use it. So it's kind of, you know, you're basically doing very similar things, except that when you're using Stripe, you're actually accepting payments, right? And so if you are the merchant, this is your way of storing payment details. So in case, you come back and you buy another t-shirt from me, that data, I mean, you don't need to type in your card number again, right? You just say, yeah, I want to pay with the last one that I had. And so Stripe knows which card that is, and it goes ahead and pays, right? In the case of Apple Pay and Google Pay, it's actually keeping a physical instrument available on your device so that you can pay any merchant with that token.
Yeah, so I guess it's kind of two sides, right? The Apple side is more what I see as a consumer, and the Stripe side is obviously what the merchant sees. And I definitely like the fact that, the Apple approach of it's stored locally, the token is stored locally on your phone, no one else has access to it, would seem like, there's no better way to do it, really. And I remember reading about Amazon coming up with a face recognition payment system, and there was a lot of questions over, is the face recognition going to be done in the cloud, so it's potentially open to being hacked and stuff like that, or is it going to be done locally, which obviously is a lot more secure, but probably not as quick to actually implement. So it's interesting that Apple have gone down that route, but Google have gone down the cloud route.
Yeah, I think Google needed to go down the cloud route, just because of the variation in devices. But at least with Apple, because they control the hardware, they're able to say, yes, it's actually stored on the secure element on your device, right? And so if you have anything less than what is an iPhone 6, I think is the lowest. If you have anything before then, there is no secure element, therefore you can't use it. But then again, that's a very old phone now, right?
Yeah, that makes sense. I guess that's just a really broad problem with the Google /Android ecosystem, is the amount of different devices, different, variants of even like screen size and the latest, version of Android and things like that. It's a lot more fragmented than.
There's a lot more fragmentation, yeah. So it almost needs to be done in the cloud. There's no real reliable way of doing it on the device for Android. I mean, it's very secure. I mean, Google security is great, but I still feel like the Apple way is better, just because it's on the device. Like, nobody else has access to it. Now, the key thing here is make sure you have Face ID or Touch ID flipped on for security. Like, there's a ton of people that just don't have any security on their phones, and it scares me. So, but yeah.
I was also curious, it sounds like, the Apple Pay it's almost like two authentications, right? Because you have to have your phone, and then you have to have a biometric way to get into it. That's very secure. Do you see a time, I imagine that's quite a good sell as well for merchants, if they want to integrate with Apple Pay, it's increased security, less fraud and that type of thing. Did you see this becoming a more widespread technology? I know Plaid recently launched in the UK QR authentication, so you could start doing a payment online and it will pass off to your mobile phone to scan a QR code, which is similar kind of level of security. I wonder, do you think this is going to be more common as we kind of go forward?
Yeah, I mean, I think just generally the whole biometric authentication of the mobile device, it's awesome. Like, especially I'll give you an idea of what happens. So I don't know if you've seen this, but at a gas station, you know how when you swipe your card and then you have to punch in your zip code, right? That was like it was like a security mechanism, you know, because there's just so much like card skimming that happens, especially at these gas stations, that it's like, okay, fine, you swipe your card. What's another thing that you might know? Okay. But even that's easy to find, you know, it's not hard to find somebody's zip code, and just be able to punch it in. I mean, in most cases, especially at gas stations, like you just look at the zip code of the gas station, and most likely it'll be the same as what you actually have, because you most likely go to the gas stations close to you, right? So it's a really easy thing to hack. And so, you know, if there was a way, so now they're starting to obviously roll out EMV at the gas station. So, you know, it'll say, please keep your card in the reader, and then it says take it out later, which is better. But still, I think the best way to do it is still Apple Pay. So you have your phone, you just like, you know, authenticate, and it just works, right? And so there's no like having to key in anything onto the touchpad, because it knows that, all right, when this person is transacting, they're actually using some sort of biometric on the device, and that's actually way more secure than, you know, punching in any sort of PIN or anything else. The chip is really secure, but there are ways to hack the chip as well. And so having this like secondary authentication, I think, is really important. And, you know, I think the other thing that's really not related directly, but there's some really fascinating things that the mobile device can actually provide, including it knows how you walk. And so they refer to it as the gait of your walk. And so the mobile device knows so much more about you than a piece of plastic could, you know? And so there are all these other factors that you can plug in that listen for these things. So if you're like a mobile banking app and you want to really secure your person, what you can do is you can watch and listen for the gait of somebody's walk and determine that this is actually that person. Or what you can do is you can even say, is the phone close by to where the physical swipe is happening? And then you can potentially even authenticate there. And, you know, the other thing that's really cool is, so the 3DS in Europe is massive. It's not as big in the US, but like having one additional like two-factor authentication for doing this is really cool. But also at the same time, it's almost like, forget about punching in a code. Like as long as you can somehow show that you've authenticated with a biometric, I think it's actually better. So I think there's like a lot more things that are coming out, but I'm bullish on just biometric authentication. I think it's really strong. And I think the way that Apple has implemented is amazing.
Yeah, I would agree. I remember when I first was driving in the US, I went to a gas station and I had to punch in a zip code, and it just completely confused me because I didn't have a zip code. My card was from the UK, so it was a very confusing process. But I guess it's just more and more things just being tied to your mobile phone, which is very convenient when you have it. It just makes it even more inconvenient when you don't have it, or when you lose it or it's stolen. You know, but
well, you have it now on your Apple Watch, right? So
it's true. Yeah, yeah. I mean, I use my Fitbit quite a lot just because it's when I'm out. Sometimes it's just easier just to have the watch there. But you know, I think as phone theft is always increasing, and it just makes it, you know, even more important to have these security measures on your phone, because if it can be stolen and used to purchase a lot of stuff, then it's a lot
absolutely.
more. But yeah, awesome.
Keep your phone locked, man. That's the most important thing. And make sure you have Find My iPhone enabled so you can wipe it when somebody steals your phone. So
yeah, it's obvious that Apple obviously sees these issues and is doing a lot to be able to, you know, if you do lose your phone, you know, it's not as difficult to you know, download your latest backup and to wipe it remotely and things like that. So they're getting more sophisticated, but you know, that there's always such an incentive for criminals to stay or try and get one step ahead that it's like a game of cat and mouse.
Yeah, no, absolutely. And I think, but I do think the tokenization is really important because of the way that, and I think it's really been kind of pioneered by companies like Stripe that have really enabled this, because they did it for the merchants primarily to like help them with the PCI scope. but you can see it being applied now to the consumer as well. And so, and even bank account authentication can be done via token if you're using something like Plaid too. And so instead of using a login password, you can also supply a token to log into your bank account. And so there's like a lot of stuff going on here. And I think people are realizing that there are better ways to secure an account rather than a username and password, right?
Yeah, I would agree. I used to do a bit of dabbling in cryptocurrencies, and the amount of times I enabled like multi-factor authentication, and then like I didn't use it for like a year, changed phones, and then trying to get it re-enabled. I mean, it's obviously that complicated for but yeah, I definitely see this as the way forward. And I think the mobile phone is going to be a big part of that. So yeah,
cool. So I hope this was helpful.
it was really helpful. Yeah, really appreciate it, and I think you definitely cleared up a lot of queries and questions I had, because I've looked online and you see tokenization mentioned, and I think it's generally designed for people that know how it works and what it is already. Yet there's not really a I don't say like a layman's understanding and a layman's description of how it happens. So
Of how
yeah,
it
really
happens. It's a good, I think it's a good topic for a blog post, Well, I think
yeah,
we can use probably bits and pieces of this talk and then see if we can put it in a blog post. Because yeah, I feel like at least the images that Stripe has provided are really good, but it's still kind of like why do you do it?
yeah.
They don't talk about that in here.
I can just see a workflow where it has the consumer, like in some of your diagrams that you had it in your book, it has the consumer on one end, merchant on the other, and it'd just be interesting to see the process of the token, where it goes, and kind of how it's stored as well. Yeah, I don't know how that might look like, but I think that those workflows, and I've seen some, I just make it so clear of like who's playing in what space, what is actually happening, what's the flow of information, and because that's really, you kind of realize that's all payment and card networks are. It's information flow.
It's all information flow.
It's just giving an instruction and passing that on. So I think those kind of workflows, or whatever, I'm not sure what the technical term is, are really, really useful in understanding it.
So I think what you're saying, if I replay this back, so there's probably one set where it's like, I'm a person that's trying to buy from an online web store, and I'm going to key in my card number, and then what happens there? So the token is actually on the merchant side altogether, and then there's the other side is I'm trying to buy a T-shirt with Apple Pay. What happens here? Because it's actually the inverse of how everything works, because it's like here the user has a token already and it needs to be decoded. On this side, you don't have a token, you're creating a token that gets encoded, right? Which is fascinating. Okay. You know, some good ideas. I got to now figure out some time to actually put something together, but I'll probably bounce it by you before we do anything. But I think it's an interesting blog post for sure. For sure.
Yeah. Yeah. And, I was also wondering, I obviously really enjoyed your book. Are you thinking of doing more book writing, or was that kind of just serve the purpose of, I think you said it was educating people at Branch about payments, but I didn't know if that was something you're also interested in doing a follow-up for expanding the scope of it, or yeah, I was just wondering as well.
Yeah, no, I mean, I think just kind of even doing the talk with your crew made me realize just a few things in that. Like, I think we just barely scratched the surface when we did the Haas talk, right? And I think there's a lot of depth that we can do there. And so I'm thinking through just generally, how do you take the book and actually like make it into some sort of like training, be it online or actually be it as part of a course, like an actual like cohort based course where you take 10 people and you put them through a like a 6-week thing where you meet up once a night or something like that. I'm still thinking that through right now. Again, it's not my day job, right? So it's like
But
I gotta build products for Branch. That's my day job, and then this stuff is kind of like, it's honestly speaking, like it's totally accidental. Just because again, I wrote the book specifically for Branch. It was just like a bunch of Confluence pages, right? And then it kind of like picked up, and I'm actually not really, I don't really know how to like manage it right now, but I got to figure that out. Because a lot of people are asking for it. I think just generally speaking, there's not a lot of great content out there for that really explains this stuff well. I think the Glenbrook stuff is good, but it's not approachable for a lot of people. And so that's what I've heard is just, can you make it simple for me? you know?
yeah, I wonder if there's like a Coursera or an online type of class to be produced. I think there'd be a lot of interest in it, to be honest. I think because, like you say, there's so much going on in payments with the different elements of it as well, and it's very confusing to people that don't really understand.